Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we are going to handle the fourth part question, and it's on some terms used in computer, or we can say used in electronics. So before we start the explanation, the notes and things like that, I want you to think of this whole thing as a body, human body. All right. Now, this guy here, the central processing unit, consider this one as the brain of the body. Are we together? Now, so we'll go and explain one by one after the other. Okay, starting from this. But consider the central processing unit the what? Brain. So the first thing is random access memory. So for random access memory, just consider this one as short memory of your brain, of the brain, what you can recall. But that's it's not something in your long-term memory, something in your short-term memory. So think of it like that. So RAM, which is random access memory, is a what? Temporal memory. This is the key thing that you should bear in mind. Temporal what? Memory. Of what? Human being. Come on, guys. Computer or microcontroller, and it's used to store data and instructions currently being processed. Whatever data that is being worked on, or worked on, all right, whatever data that is being processed, I think that's a better way to put it. Now, and that's the data that is being stored in where? RAM. Okay, and you can see that in our phones. Okay, your phone, how many gig RAM? Oh, my phone is this gig RAM, it's 4 gig RAM, 2 gig RAM. It means your phone can process data up to 4 gig, okay, at a time. That's the meaning. RAM. Okay, it's not the same as your other memory. Okay, right. So it allows fast read and write operations, but loses its content when power is switched off, making it a volatile memory. I believe that's clear. Short memory. Okay, memory. Now, for electrically erasable programmable read-only memory, which is what? EEPROM. Electrically erasable, which means it's electrical, and yes, we can erase it. Like, it can electrically be erased, all right, and it's programmable, and you do not write to it, you can only read from it. Note, when we say read, we mean get data from that memory. When we say write, we mean put data into that memory or space or location. So read, you are getting from. Write, you are putting in. All right. So EEPROM is a non-volatile memory. Volatile mean the data is lost once power goes off. Non-volatile meaning even when power goes off, we still have that data inside safe. Okay, the data that's inside is still inside. Okay, so it's a non-volatile memory that stores data permanently. Are we together now? Even when power is removed. Okay, so it can be electrically erased and reprogrammed, making it useful for storing configuration settings, password, and calibration data in embedded systems. Okay, think of it. Come on, guys, think of it. If you have two memory, you have random one that power goes off, that one that loses its data when power goes off, and the one that retains its data when power goes off. Come on, if you want to save something and things like configuration, password, and things like that, you save them in where? EEPROM. All right. Now, the next thing we are asked to write a note on is flash memory. Flash memory is a type of what? Non-volatile. It's also non-volatile, which means when power goes off, it retains its what? Data. So, it's a type of non-volatile memory used for what? Permanent storage of data and program instructions. So it allows data to be erased and rewritten in blocks, and is commonly used in USB drives, memory cards, smartphone, and microcontrollers. Okay, this guy, this guy, you can it retains data, but it was read only. There is no write. For this guy, you can read and you can what? Write. Now, for central processing unit, I already said that it's like the brain. Okay, for all these guys, they are like memory. They are memory, not like they are memory. Okay, so from A to B to C, what? Memory. Then for this guy is the brain. The central processing unit, CPU, is the main processing component of a computer system. It executes instructions, performs calculations, and controls what? Overall operation of the computer or microcontroller system. Are we together now? Now, with that being said, the next thing we have here is what? Control units. So when you hear control units, of course, that is the part that gives command. Yes, the central processing unit process, but this guy is what? Gives command, control signals. So the control unit is part of the CPU. Inside your central processing unit, the brain, this control unit is located inside it. Okay, so all the processing goes inside the CPU. Okay, that's the central processing, not all, but central processing goes on inside the central processing unit. It's a unit. Okay, and the unit contains control units. Now the control unit is part of the central processing unit for coordinating what and controlling, coordinating and controlling all computer operations. It interprets instructions and directs the movement of data between CPU, memory, and input and output devices. Now, even arithmetic and logic units, okay, ALU, the arithmetic and logic unit is the section of the CPU, meaning it's also inside the CPU. Are we together now? So, it's a section of the CPU that performs what? Arithmetic operations such as addition and subtraction, as well as logical operations like comparison and decision. Okay? Then for G, we have registers. This is also a memory. Okay, guys, this is another memory, but what? They are small. Registers are small, high speed. They are small and they are what? High speed memory location located inside the CPU. Okay, so when data comes into the CPU to be processed, of course it has to the data has to land somewhere. That somewhere, that's where registers come in. Those data have to land on the register or be received and saved temporarily inside the register or inside one of the registers. Okay, so they temporarily store data, instructions, and memory addresses currently needed during processing. Now, clock. The clock is an electronic timing device that generates regular pulses used to synchronize the operation of the CPU and other computer components. Now, when you hear clock, just so on, off, on, off, on, off, on, off. But it's when you say you want to carry out an instruction, so one clock pulse, one instruction, another clock pulse, another instruction. Okay, so but we have a lot of clock like clock pulses per second. Now the clock speed determines how fast instructions are executed. So if we have a clock speed that completes a higher number of cycles or clock, let me say tick, okay, per second, which means that clock has a higher speed, higher clock or higher circles, complete circles per second, higher tick. Okay, let me use the word tick. Higher tick, like tick, 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 tick. If you have more in 1 second, that clock is what we say is very what? Fast, or we say it has a high clock speed. So the more clock speed you have per second, the more instructions you can execute per second. More clock speed, a higher clock speed, faster instruction or more instructions executed. Okay, now the next one is what? Input and output. This is IO ports, meaning input and output ports. So an input and output, which is IO port, is an interface used to connect external devices to computer or microcontroller. They are like your let's say sense organ, okay, eyes, ears, okay, your skin, okay, tongue, and nose, perceive, okay, they're like the sense organ of the computer, input and output devices, okay. Then it allows communication and data transfer between the system and peripheral devices such as keyboard, sensors, and printers, and things like that. even in monitors. Okay, so then the last one, bus. This is the bus. A bus, okay, bus is a communication pathway used for transferring data addresses and control signals between components of a computer system, such as the CPU, memory, and input and output devices. Now, when you see physical conductors, like you have uh, you have one component here, you have one component here, you have another component here. There has to be conductors carrying electrical signal from one component to another component. This conductor, of course, in electronics on printed circuit board, these conductors are just like lines. Those lines are referred to as what? Buses. Are we together now? So that's for this video. Okay, thanks for watching and see you in the next one. Bye for now.